Typical residential buildings were intensively built in Riga and other Latvian cities during the years of Soviet Latvia, namely from the beginning of the 1950s until the 1990s. In Latvia, 70% of houses that were built during this period need to be repaired. The insulation of multi-apartment buildings has been a major issue in Latvia. Most often this happens due to limited education of citizens with respect to energy efficiency and renovation, leading to their unwillingness to pay for it. The Energy Efficiency Investments De-risking Service has been developed by ICCS, in the context of I-NERGY Horizon 2020 project and specifically for the Riga Energy Agency pilot from Latvia. The purpose of this service is to guide Latvian citizens in creating virtual energy performance certificates for their residential buildings and subsequently explore the costs and benefits that occur by various energy efficiency renovation actions of their preference. Such a service is crucial for Riga Energy Agency in educating and motivating Latvian citizens to get familiar with renovation concepts and therefore promote energy efficiency within the country. In the same context, the Energy Efficiency Investments De-risking Service provides measures that will help deliver more predictable returns for investors, reduce transaction costs and enable private capital flow into the market. Therefore, it can contribute in identifying which investments are realistic and feasible within a national and sectorial context, as well as how they could be financed in practice in the short or medium term, aiming at higher quality renovation projects in the future. From a functional perspective, every time the user triggers the process, a new virtual energy performance certificate is issued, allowing them to visualize, through comprehensive analytics and graphs, the energy performance gains provided a batch of selected actions, alongside the respective investment costs. The core of the service is data-driven, meaning that the user only needs to input minimal information about their building, such as address and building type, and then a neural network automatically estimates the energy performance certificate properties based on Riga Energy Agency's archive and databases. From an architectural point of view, the service has been developed using JavaScript, React and Python as the main frameworks for the front-end and back-end respectively, while Docker has been used for containerization and deployment purposes. Specifically, the backend was implemented using PyTorch Lightning and scikit-learn for the machine learning operations alongside Fast API for API development and SQLAlchemy for communicating with the dedicated Postgres database. Regarding the front-end, it has been developed using the React library. For the CSS part, Material UI has been utilized. Finally, Leaflet.js was used for the map visualizations, while Chart.js was used for the chart visualizations. Let us now proceed to the demonstration of the Energy Efficiency Investments De-risking Service and the functionalities of its dashboard. With respect to identity and access management, two main user roles have been created using the Keycloak client. Specifically, an end-user role and an administrator role are provided. Aiming to demonstrate both of them, we are about to log in as administrators, as the functionalities of this role are a superset of the end-user role. This is the homepage of the application. The main functionalities provided by the dashboard are displayed here. It is a fully responsive page and the same applies for the whole front-end application. Noteworthy, the whole application is bilingual, since every page can be displayed either in English or in Latvian. Changing between the languages is possible by the drop-down menu on the top right of the dashboard's header. Let us demonstrate that, by switching between the languages here on the homepage. The same applies to all the other pages of the application as well. Now let us navigate to the Plan Investment page. Here a list of the available stored addresses is loaded for the end user. The user can choose one of them and following they are prompted to choose between a number of pictures the one that is more similar to their building. Note that upon choosing an address a responsive map also appears displaying the exact location of the chosen building, therefore allowing the end user to confirm their input. Additionally, the calculated perimeter of the building is also displayed. Let us also demonstrate how the bilingual feature works here as well. Pressing the Virtual EPC button, the end user is navigated to the next page, where the calculated energy class and total energy consumption of the building are displayed. Additionally, two informative charts regarding district heating energy consumption and total heat losses are displayed. In the section below, a variety of energy efficiency measures are listed. They are separated into 6 distinct categories and their estimated cost is also shown to the user, who can choose one or more of them. An indicator of the total cost of the chosen measures is also available, being updated every time the user selects or deselects a measure. Having chosen at least one energy efficiency measure, the end user can press the Calculate button. Upon doing so, a pop-up window appears showing the expected results after applying the selected energy measures, in terms of new energy class and total energy consumption, as well as the total cost that would be needed. Having seen the calculations and estimations described, the end user can experiment with other measures and see the expected results by going back to the previous page and repeating the process. The administrators of the tool have also access to the Energy Admin Measures page. In this page, all the available energy efficiency measures are displayed in table form. Various properties of the available energy efficiency measures are available to the admin for editing or deletion. Additionally, by pressing the Add New Measure button, the admin is navigated to a new page form in which they can add new energy efficiency measures, alongside all the required details for each one of them. Finally, a profile dashboard is also provided, including user data and available roles. In the end, a Sign Out button allows the user to exit the application. Thank you for watching this video. Join our network to learn more information about I-NERGY project.